Welcome to our lesson on variations. This is a continuation. We're continuing on variations. We looked at direct variation in our previous lesson. So here we're going to look at indirect or inverse variation. Indirect or inverse variation. Then we'll also look at composite or combined variations, and look at a few examples. So for indirect variation, like we saw earlier on direct variation, for indirect variation, the steps are also that we first identify variables, though usually in the exam situation these variables already come identified, but for the sake of procedure, let's say we identify the variables that vary indirectly. Then the second step is the notation of inverse variation. The notation of inverse variation. So what is the notation of inverse variation? Now we know from the word inverse, simply means we are getting the reciprocal of a quantity. So for example, if you have y, then we say the inverse of y. So the inverse of y, or the reciprocal of y, is 1 over y. So the idea of inverse variation gives us this understanding that we are dealing with the reciprocal of a given quantity. Now we need to look at these two quantities that are inversely variable, or they vary inversely or indirectly. So the notation, if for example y varies inversely as x, okay, if y varies inversely as x, then the notation is given as y varies inversely, which means the reciprocal of x, and the reciprocal of x will be 1 over x. So that will be the notation for inverse variation. If y, for example, varies inversely as w squared, if y varies inversely as w squared, then the notation will be something like y varies inversely as w squared. So in other words, the word inverse or indirect variation simply means you invent one variable. Okay, you get the reciprocal of one variable. That is the one that you're going to introduce to the situation you've been given. And so after the notation, you can get to the equation in K, the equation in the constant of variation. From the notation, we can generate the equation, or we convert the notation to an equation in the constant variation, constant of variation, equation of variation. we formulate the equation of variation, or simply the equation in K. So for example, if y, as we are saying, if y varies inversely at x, okay, if y varies inversely, our notation is that if y varies inversely as x, we are saying, this is for direct. So if y varies inversely meaning that, so if y varies inversely as x, the equation in K will be y is equal to the constant of variation, just like we saw earlier. Constant of variation will multiply that reciprocal, okay, which can be rewritten as y is equal to k over x. Okay, if we try to look at the other example, which says y varies inversely as w squared, then the equation in K will be y is equal to k times this inverse, which is 1 over w squared. So this can be written as y is equal to k over w squared. So that is how we get the equation in K. Then after getting the equation in K, the next step is to substitute the initial condition and solve. So we substitute and solve. Substitute the initial condition and solve. So for example, let's take an example. Okay, let's say y varies inversely as x squared. Let's say y varies inversely as x squared, and y is equal to 1 when x is equal to 2. Okay, let me just get that statement again. Given that y varies inversely as x squared, okay, given that y varies inversely as x squared and y is equal to 1 when x is 2, then what will be the value of x? What will be the value of x when y is 4? What will be the value of x when y is 4? Okay, so since this is inverse variation, it means we're going to start with our first step. Of course, we are saying the variables that are varying here. We have y, which is varying inversely as x squared. Okay, so we need to get the notation right. What is the notation? Since y is varying inversely, we will have our notation as y is varying inversely as x squared. That would be the notation. Then what would be our equation in K? Our equation in K would be y is equal to K multiplying 1 over x squared, okay, which we can rewrite as y is equal to K over x squared. That is our equation in K. Therefore, we can use the available information to find the value of K, find the value of the constant of variation. So, for example, here we are told when y is 1, x is 2. So we can substitute this information to know what the K is. So where there is y, we put 1 equals K over x is 2, so it means 2 squared. So it means y is equal to K over 4, K over 4. So we can solve this. We cross multiply here so that we find the value of K. It means K is equal to 4. Okay, K is equal to 4, meaning the equation of this variation is y is equal to, where there is K we put 4 over x squared. Okay, that means this is the equation of variation that is determining the values of this relation, right? So with this equation, we can now use this equation to find whatever missing values that we are looking for. So for example, we can say if y is 4, what would be the value of x? Alright, so we'll say y is equal to 4 over x squared. Okay, now that is our equation of variation. So when y is equal to 4, when y is equal to 4, we simply substitute in the equation to solve. So where there is y, we put 4, which is equal to 4 over x squared. So when we cross multiply and solve this equation, we'll have 4 times x squared is 4x squared, which is equal to 4 times 1 is 4. We can find x squared by dividing both sides by 4, which means x squared is equal to 1. So if we are solving for x, it means we square root both sides, so that we say x will be equal to 1. So in short, when y is 4, the value of x, according to this relation here of inverse variation, according to this relation, when y is 4, x is 1.